Okay, thank you, Omkar. Uh, so, uh, am I audible?
Yes.
Hello?
Yeah,
Okay. So, now get to our CADbusters, that is CAD session. Okay, so this is basically the session consists of CAD, CAM, and CAE. That is very basic of the CAD softwares. Okay, so let me know how many of you know any of the names of the CAD softwares. You can text in the chat box. Anyone know about any software? Okay, right, AutoCAD. Yeah, SolidWorks. Great. So next slide. Yeah. So what is CAE now? That is CAE stand for Computer Aided Engineering. So the softwares you have told just now, or and other softwares like SolidWorks, CATIA, and SIS Fusion 360, all the softwares are included, which aids in design, analysis, and manufacturing tasks. Either it be giving properties or applying conditions. All the softwares are included in this CAE only. So, what does CAE do? CAE simulates the performance in order to improve the product designs. It's like the problem solver for all the engineering applications. uh, it helps in designing the prototype. So this includes the simulation, validation, and optimization of products using the manufacturing tools. It also helps in decision making as can the prototype be converted into a final good product. Next slide. Okay, a typical CAE simulation comprises of three processes. So, have any one of you visited any R&D research centers or the product manufacturing labs? You may have seen that there are three steps. They create a prototype. They give certain conditions like the temperature, thermal capacities, or the pressures applied to the prototype, and this conclude the results as is the prototype is really useful to us, and they apply the prototype as they want. So here in the software also there are same three processes: pre-processing, solver application, and post-processing. What we do in pre-processing is we upload a CAD model. That is, we design the CAD model and defining all the measures and environmental factors like which material is used, which thermal capacities the product have. Next is solver application, that is actual creation and running of the simulation. Like uh, if we create a assembly, then we discuss that is this assembly really useful, or does it have that use in actual life. The third is post-processing steps, that is validation of the model. The software gives you the calculated results in the form of chart or graph or table. We can 3D visualize the what is happening. Like take the example, you have in 11th or 12th, like some force is applied to the object and the object will move this much distance. Okay, so all this we can get to know from the 3D visualization in the softwares. Next. Okay, so this part is really interesting. That is CAE applications. Other than CAD and CAM, that is design and manufacturing, there is a part called as analysis. So CAE applications consist this analysis. Uh, in CAE applications, there are stress and dynamic analysis on components using finite element analysis. So FEA, that is finite element analysis. What is it consist of? It is consist of loads and constraints. We can give the stiffness or compile any numerical by this stress and dynamic analysis. It is basically used in aerospace industry to give the thrust or the pressure on the certain component or part. Second is thermal and fluid analysis using computational fluid dynamics, that is CFD. So you have studied the thermodynamics in 11th or 12th, right? So you know that there are fluid gas, and fluid liquid interactions between the molecules. So all the problems related to that, related to lift and drag or pressure and volume, are solved by this thermal computational fluid dynamics software. Third is kinematics and dynamic analysis of mechanisms. That is a multi-body dynamics. Consider that you have a wheel assembly. Okay. So in wheel assembly, there is a wheel hub, piston, and shaft. So how the all the elements in this assembly work together, that is which motions are restricted, which will happen, all we get to know by the visualizations given by this multi-body dynamics. Fourth and fifth are mechanical event simulation and acoustic analysis using FEA. These two are done by MES and BEM softwares. There is a boundary element method, that is, we apply the force on the boundaries of the product, and it is integrated throughout the product. And in mechanical event simulations, there is a very good thing, that is, we can simulate for the large deformations and also for rigid and flexible bodies. It also includes the impact test on the products. Next. Okay, so benefits and advantages. Basically, in the past, what we do is, by the conventional methods, we create a whole setup, which consists of all the materials, and which consumes very much time to design the final product after very much attempts. So by this software, there is a reduction in time in the product development. There is also a risk reduction, as we can predict the by the softwares prior to designing. There is improved product quality and reliability, uh, which will be discussed in the CAM session. And there is possibility to make corrections early in the concept and design phases. There is a reduction in cost, as the we will use the less material and less experimental setup to create a prototype. There is a keep there we can establish certain deadlines in different phases of engineering workflow with the help of this software. And last is the product life cycle extension, that is, this software determines that is this product is really usable, or we can launch the product in market, what needs we, or what designs we have to improve, what needs we have to taken to launch this product into the market. Next. So last, what does CAD and CAM means? You all have studied the engineering graphics, right? So you know the so let me know if you have drawn an ellipse and you have taken certain wrong dimensions. So by using if you are using this software, you do not have to again redirect all the elements. You just can modify and analysis your designing in different ways, like right view, front view, and top view. So CAD is use of computer systems aids in creation, modification, analysis, and optimization of a design. So it is useful for engineers, architects, designers, and drafters. If we are computer models are created and defined by geometrical patterns, like if you are given any dimension to the 2D, and you want to change it according to your assembly, so you do not have to recreate for the whole model. You can just change that dimension in 2D, and it will automatically reflect into the 3D model. The CAD allows the designers to test the objects by simulating real-world conditions. This happens through the ANSYS or CATIA-like softwares. It can design anything from a simple shampoo bottle to a complex jet plane. Next. So last is CAM. CAM basically includes the application. That is, we have created a certain model in CAD and CAE and analysis it through the CAE. But how to convert it into a real life model. This is done by the CAM softwares. It works in assembly with the machineries used in manufacturing processes. So, uh, CAM CAM converts the past conventional automated machinery into a new controlled automated machinery. This happens through the CNC, that is computer numeric control, or DNC, that is direct numerical control systems. So they what they do is they if we put a certain CAD model in CAM, the CAM model converts all the geometric data, they encode it and create a real life model through the machineries. So the main purpose of CAM is it involves the faster production process. Due to less in human errors, all the components have precise dimensions, also the material consistency. So now Tanaya will guide you on next session.
After knowing what is CAD CAM and CAE, let's see what is difference between these CAD CAM and CAE, their applications and example. The main difference between CAD and CAM software is that CAD software are used for designing a tool or product, and CAM software used to actually manufacture the product by giving commands to manufacture machines like CNCs. Many CAD vendors market fully integrated CAM systems called CAD-CAM systems. These CAD-CAM packages deliver many advantages, such as for starters, they feature a common user interface that allows CAD operators to quickly learn the software. It uses can easily transfer CAD data to the CAM system without worrying about translation errors or other difficulties. And finally, some integrated systems provide full associatively, which means that any modification to CAD model will prompt the associated toolpath to be the automatically updated. And CAD has completely changed the drafting business and made the storage and retrieval of projects much easier nowadays. Next slide. Now see what is CAD-CAM software. Uh, CAD CAD-CAM software is used to design and manufacturing prototypes, finished products, and production runs of products. Their applications are used for both design a product and program manufacturing processes, specifically CNC machining. And CAM software uses the models and assemblies created in CAD software like Fusion 360 to generate toolpaths that drive machine tools to turn design into physical parts. This CAD-CAM software also used to manufacturing prototypes, finished parts, and production runs. Next slide. Now, what are where these CAD/CAM software used? Let's see uses. First one is in aerospace. The aerospace industry manufactures machines and their parts, such as satellite aircraft and missiles. Because these are high ticket items, CAD/CAM software has a very important role in this industry. Next one is fashion design. CAD/CAM is used for mass production in fashion companies. Uh, they determine the most efficient cut of fabrics and adjust the pattern scale for different sizes. It can even be used to portray how the clothing will fit and move. Next slide. Next one is in dentistry. CAD/CAM used in dentistry to digitalize dental structures and the oral cavity for the virtual design and both simple and complex prosthetic units. Next one is automotive. CAD-CAM software is used to create 3D prototypes of new automotive body staples and to design components such as tires, engine, circuit boards, etc. And it also used in forensics to estimate ages and conduct injury analysis and post-mortem identification. The software can provide 3D reconstruction of crime scene investigations. Next slide. After knowing this brief information about CAD-CAM and CAE, let's take information in short. What is difference between these three? Uh, uh, as I told, CAD computer-aided engineering is used to design, visualize, and simulate new product designs, and it includes SolidWorks, CREO, Fusion 360, NX, AutoCAD, etc. And computer-aided manufacturing, that is CAM, is used to automate the manufacturing processes, and it includes SolidWorks, CAM, CAMWorks, HSM, MasterCam, PowerMill, Fusion 360 CAM, etc. And computer-aided engineering is used to simulate the product design before actually building in it, and it includes ANSYS, Flowtherm, SimScale, MasterCam, MATLAB, LS-DYNA, etc. Next slide. Uh, Now let's see one example, so you will understand better in better way what is CAD-CAM and CAE, and it is what is in which it is used. Example is designing a gun. Uh, while designing a gun, CAE will be used to test the working of the gun. This will be done after designing is completed, and if any flaws are found in the design, they can be minimized. Uh, and CAD used for actually designing the gun. The parts like spring, bullet, stock, barrel, etc. will be designed, and CAM will be actually manufacture the gun by giving commands to manufacturing devices such as 3D printers, CNC, etc. So this is all about CAD CAM and CAE, and I hope you all understand this concept very well. Thank you.